Hello, and welcome to another problem-solving session with Special Maths Academy. We'll be looking at another problem from the Nigerian Mathematics Olympiad, the third round, 2021. So let's go straight into the question. So it says, find all triples of primes P, Q, and R such that P to the power of Q is equals to 2021 plus R cubed. Okay. So the first thing is, we just try and compare some parities. Okay. So the first thing is P is equals to 2. So let's try and prove this. So we take mode 2 of both sides. So we see that P to the power of Q mode 2 is congruent to P. Because if P is even, no matter what number you raise it to, it's still going to be even. And if P is odd, no matter what number I raise it to, it's still going to be odd. So the parity remains the same. Okay, 20, so mode 2. 2021 is congruent to 1 mode 2. And as before, R cube is congruent to 1 mode 2. Okay, so let's compare this. So we have that P is congruent to, so from P to the power of Q equals to 2021 plus R cubed. So we have P is congruent to 1 plus R mode 2. Okay, so this implies that if P is congruent to 1 mode 2, then R is congruent to 0 mode 2. Okay, so if R is congruent to 0 mode 2, since we're talking about primes, it implies that R is equals to 2. And if R is equals to 2, what do we have? We have P to the power of Q equals to 2021 plus 2 cubed, which is equals to 2021 plus 8, which is equals to 2029. Okay, so we have P to the power of Q is equals to 2029. But 2029 is prime, so this would force P to be equals to 2029. And if P is equal to 2029, it implies that Q is equal to 1. But then this is a contradiction because 1 is not a prime. Okay, so this implies that P is equal to 2. So if P is equals to 2, what else can we do? We can take modular the congruency mode 3. So I'll just quickly erase this. So let's take this. Let's take the congruency of both the residues of both sides mode 3. Okay, so sorry about that. Okay, so back. So now, if X is congruent to 0 mode 3, so we'll just test some things, then X squared, so if let's just go to X cubed, then X cubed, so this implies that X cubed is congruent to 0 mode 3, and actually vice versa. If X cubed is congruent to 0 mode 3, because 3 is a prime, so this implies that 3 divides X cubed, and because 3 is a prime, it implies that 3 divides X. Okay, so it's just vice versa. And then look at other congruencies, other residues. So before we take the residue mode 3, let's bound Q. So now we have that P is equals to 2. So this Diophantine equation, P to the power of Q equals to 2021 plus R cubed becomes 2 to the power of Q equals to 2021 plus R cubed. And 2021 is bigger than 2 to the power of 10. 2 to the power of 10 is equal to 1024. So 2021 bigger than 2 to the power of 10. So we have 2 to the power of Q is bigger than 2 to the power of 10, and so Q is bigger than 10. Okay, so since Q is bigger than 10 and Q is a prime, it implies Q is odd. So Q is odd. Okay, so let's erase this and continue with the question. Okay, then next we have if X is congruent to 1 mod 3, then we have that X squared is also congruent to 1 mod 3, and then X cubed is also congruent to, so X cubed is congruent to X mod 3. So X cubed is congruent to 0 mod 3, so we can just simply put X cubed is congruent to X mod 3. And then we see if X is congruent to 2 mod 3, then X squared is congruent to 4, which is congruent to 1 mod 3. So X cubed, so let's multiply both sides by X. X cubed is congruent to X mod 3. So this implies that X cubed is always congruent to X mod 3 for X integers, okay? So always. So for all X member of integers. So when we take the residue of this Diophantine, of the both sides of this Diophantine equation, mod 3, we have that P to the power of Q. So sorry, since we already have P is 2, so I have 2 to the power of Q equals to 2021 plus R cubed. So when I take mod 3, this 2 becomes minus 1 to the power of Q congruent to, so 2021. The remainder when this is divided by 3 is, so you can say this is minus 1, so plus R cubed mod 3. So a quick way of finding the residue mod 3 is just by adding the digits of the number and dividing it by 3. So when we add the digits and divide by 3, we actually get 2, but I just decided to put minus 1 because 2 is congruent to minus 1 mod 3. So now we have that Q is odd, so minus 1 to the power of Q is going to be minus 1. So I have minus 1 is congruent to minus 1 plus R cubed mod 3. So have that 0 is congruent to R cubed mod 3. So R cubed is congruent to R. So recall what we did. So we have that R is congruent to 0 mod 3. So this implies that R is equals to 3. So, and once we have R is equals to 3, it's almost set from there. So I'll just erase this here. So I have 2 to the power of Q equals to 2021 plus 3 cubed, which is equals to, so 2021 plus 27, which is equals to 2048. So 2048 is equals to 2 to the power of 11. So we have that Q is equals to 11. So Q is equals to 11. So the solution to this Diophantine equation is PQR equals to 2, 11, 3. Okay, so that's it. But frankly, looking at this question again, I don't think it's necessary to make P prime. So if P was not made prime, then we'll have two solutions. Sorry, if Q was not made prime, then we'll have two solutions, because recall that we had earlier got 2029. So the other solution, the other possible solution would have been, so here P was 2029, Q was 1, and R was 2. Okay, so this would have been the other possible solution would have had. But then they said all of them are primes. So yeah. So this was not a bad problem. So that'll be all for this video. See you in the next video. Goodbye, guys.